Hello, everyone. Welcome to our series, Delivering Self-Service Private Cloud. Today, we're diving into the world of Kubernetes automation with VMware Cloud Foundation.
Join us as we explore how VCF Automation simplifies the management and scaling of your Kubernetes environment in VCF.
In our previous episode, we led the foundation for self-service private cloud. Now today, we'll deep dive into the Kubernetes capabilities of VCF Automation.
Yeah, so VCF Automation empowers you to define, manage, automate your Kubernetes infrastructure, ensuring efficient and scalable operations. So Satya, let's get started.
Yeah, let's do it.
Okay, so you have seen this slide in our previous episodes as well, in two previous episodes. So we're going to stick around with this slide to set the stage. Once again, I want to reiterate that Audio Automation is an automation solution empowering the VMware Cloud Foundation. It delivers a self-service with governance and resource lifecycle management across VMware clouds and the public cloud, as you can see. So this is a snapshot of several features. So we covered some of them in past, like infrastructure as a code, the AVI load balancer, network automation, the policy and governance. So this is the snapshot of several features or the areas that we're going to focus throughout this series. So in this episode, we will focus on another core capability, Satya, which is Kubernetes automation. I'm going to cover a cloud consumption interface. We call it as CCI, that enables users to leverage the supervisor and associated services to deliver the simple self-service consumption of Kubernetes environments, cloud resources throughout the Kubernetes construct, as well as the VM form factors as well. So VMware Cloud Foundation includes an embedded Kubernetes runtime, because I want to focus on this, that when you get the vCenter not only provides you the VM form factors, but now we have embedded Kubernetes runtime that enables the customers to accelerate modern applications deployments as well, which is essentially now your development teams can increase the productivity and support the advanced microservices-based architectures and the workloads as well using the cloud-native technologies.
Right. Okay. And it's all right from VCF Automation itself, right? Using their catalogs that we will create, and then also that we will distribute to the consumers.
Exactly. Right? I mean, with this, we're going to still stick with the consumers and the providers persona. This is where the providers really going to curate those blueprints, the cloud templates using the Kubernetes construct, and then offer those to the consumers so that they can do this wherever they need the Kubernetes runtimes or Kubernetes clusters and things like that.
Exactly. And similar to how we saw in our last episode, it will just be available to them as a catalog, right? And they can just go and self-service themselves, isn't it?
Right. If you see the result, essentially you're going to deploy the applications in a faster manner. Yes. You can consolidate the workloads that utilize both of the best worlds, like containers as well as VMs, providing a greater ability and scalability across your cloud endpoints, right?
Yeah, exactly. And that's the power, right? That's the power of VCF. That it's not just the traditional VMs only, but now it supports all of the modern apps, right? With Kubernetes, microservice architecture, everything.
Exactly. And this is where we really want to focus, whereby your developers increase their productivity, the consistency of traditional and DevOps environments as well, with both of the best worlds.
Yeah, absolutely. Yeah, faster time to deployment and all of that, right? Yeah.
Correct. So now I'm going to touch base a little bit into what are the building blocks of this IaaS platform. So we start out with the virtual infrastructure, that is compute, networking, and storage, and all the management products that are part of the VCF today that has been used by many of our customers throughout, right? So in order to enable the declarative APIs, we have enabled the supervisor. So supervisor service is basically part of the TKGS service that comes embedded with this runtime within the vCenter.
Yes.
The supervisor comes with built-in services that helps you consume underlying infrastructure, such as network services to deploy the load balancers, storage services to deploy the persistent volume, PVC volumes, and not only compute and network and the storage, but also the VM service that allows you to self-service, declarative, define virtual machines, and TKC service for deploying your Kubernetes cluster, right? We call it TKC clusters. And beyond that, basically, we have added additional services that helps us extend the capability of IaaS platforms, such as the Harbor, the image registry, the OCI image registry, the DSM, which is basically our database management systems. So we can deploy the DBs, databases, using this supervisor service as well.
Yeah, right. Like for our viewers, myself and Vincent, we did a deep dive series just a few months ago on Kubernetes in and on VCF. So if you haven't watched that series, please go ahead, because it actually covers all of these aspects in a really great depth.
Yep, absolutely. And also from area automation standpoint, we're going to also apply some management governance layer on top of this. This is where the providers can define the quotas, the policies, the approvals, and for the platform consumption as well.
So exactly. Everything automated, right? Yeah.
So through our customers' conversation, we are hearing that many enterprises need a true cloud experience in a private cloud environment, right? So consumer want to use Kubernetes-based interface for orchestration and their infrastructure and workload requirements. Some of them, prefer to use the Kubernetes CLI, which they are familiar with. Some of them are really preferred using UIs and the APIs. So whatever the requirements, right? And in fact, I just want to add, some of the customers that I have spoken, they also want to use Git operation-based infrastructure as a code. And we have covered that in the previous episode, how we can do Git operations as well with the automation tool that we are covering here. Regardless whether you want to use the CLIs, UI, API, or Git operation with the Kubernetes ecosystem, this is where we're going to use our IaaS consumption interface. So you see CCI there, which is the cloud consumption interface. Essentially, that's going to help the customers to really embed and use all these technologies, and then they will still able to spin up the resources. They will still able to consume the resources in the Kubernetes form factor as well.
Got it. Yeah.
Okay, that's the main slide for today, which we're talking Kubernetes automation. Basically, as you know, many of your developers are trying to deploy applications on the Kubernetes cluster. However, sometimes it can be very complicated, right? And it could be a time-consuming process. So VCF Automation empowers the cloud consumers, enable them to provision the Kubernetes infrastructure in form of TKGS clusters, Kubernetes upstream conformant clusters as well, and apply some day two operations on it. For example, scale out your control plane nodes, scale out worker nodes, attach persistent volumes, do rolling updates, change the Kubernetes versions of the TKG clusters and things like that, right?
Right.
Essentially, when your developers who prefers to use Kubernetes for application orchestration will really appreciate this flexibility and adaptability of your VCF automation. They can use the Kubernetes manifest to provision the VMs and the TKG clusters as well, using a self-service capabilities.
Cool. Yeah. So a lot of flexibility here.
Yep. So stitching everything together, again, our focus is going to be Kubernetes automation with the cloud consumption interface, which is CCI, and it is part of the area automation, or we call it VCF automation 8.16.2. So as long as you have 8.16.2, you can able to consume the cloud consumption interface, which provides a simple and secure self-service consumption of your Kubernetes-based desired state IaaS API platform, which essentially gives you those Kubernetes construct. Yeah.
Okay. Yeah.
All right. So we're going to see this in a demo, but high level, this is what you're going to see when you log in into your self-service portal. Provide a namespace construct. This is where you're going to create the namespace, the supervisor resources, as well as the TKG resources from here.
Right.
And just something recently we added into the product, which is called CCI templates elements. With 8.17.0 area automation, we introduced the CCI templates element. So what are these, right? So which is basically allow the administrator or the provider to use the CCI framework that we spoke about in the blueprints or the templates now. So with the cloud consumption interface, the previous experience that I spoke about was directly from the self-service portal, but not so much from a blueprint standpoint or not so much from a catalog standpoint. Previously, you directly log in into the self-service portal and start consuming it, rather than publishing those as a catalog. So now with this CCI templates element within the area automation 8.17.0, you can package the CCI elements into a template and then publish these templates as a catalog. And then the consumers will consume these catalogs, just like what we have seen in the previous episode, where they deploy the AVI load balancers, the application and everything using just a simple catalog.
Right. So it's directly available for our providers to create catalog and then consumers to consume from self-service catalog, right? Yeah. This is
So you can see this. There are 3 constructs that we added recently, or we call it as 3 CCI resources that we introduced within the library. So if you search into our design canvas that you have seen in the past, search for CCI, you will see these 3 resources. You will see that we have supervisor namespace resource, which going to allow us to create the supervisor namespace, and we will take a look at that, what code it requires during the demo. And then you have the supervisor resource, the second option, which is really allowing us to create the resources within the namespace that we create. So first is the supervisor namespace. Second one is the supervisor resource. So supervisor resource is something that we create within the supervisor namespace. It could be construct like a VM service, TKG clusters, load balancers, storage volumes, images, and things like that.
Got it.
Right? And finally, the last one that you see there is the CCI element called as TKG resource. Now, what is the TKG resource? This is like 101 upstream Kubernetes resources that you want to create within the clusters. For example, you have TKG cluster created. Now, within the TKG clusters, you want to create a service. You want to create a deployment. You want to apply different secret policies and things like that. You can do that using the TKG resource.
Yeah? These are the Kubernetes elements itself, right?
Exactly. That's how when you package this everything together within a template, you can create something like this. And I just want to call out the AI services that Broadcom offers as part of the VCF with the additional licenses. Once you enable the license, you could able to create those AI related construct as well, like AI workstations, the RAG pipelines and things like that.
And those AI workstation elements are also Kubernetes based, right? Most of them.
Yes.
Cool. Awesome. So this is really helpful. Yep.
Yeah. So that's pretty much I wanted to cover in terms of the slides. Now let's dive into the demo.
Yeah, let's go to the demo.
For it.
Absolutely, man.
Look, I have logged in as the cloud admin, right? This could be any of your role-based access control user, such as Pramod or corporate IT user and things like that. Let us keep it simple. So now, this is the service broker, which is our self-service catalog.
Yes.
Over here, you can see supervisor namespace, right?
Right.
So that's the CCI capability being offered as part of the self-service consumption.
Yes.
Now, you can see here, I have already created two namespaces like CIA demo, ESA demo. In case you want to create a new namespace, obviously you can click on the create new namespace. And there are some underlying supporting elements here, such as your supervisor namespace class, such as region, which region you want to deploy this, depending on your clusters and the workload domains that you define, right? This is already predefined as part of a pre-work, right? Anybody needs more detail onto it, let us know. We can share the documentation, what you need to do to create this construct beforehand. Now here, I can call this episode 3 demo. Okay, that's the interface. And then where do I want to deploy this? Which region? This is into my Singapore BBC. And the namespace class is gold, already predefined. The project mod is already defined in Area Automation. Right? So I say create, and now you can see it's being created. Okay. Now if I go into this, obviously it's still creating it, so it's not active. But within few seconds or within some time, we should be able to see this fully ready. Okay.
Right.
Now, while this is creating, I can walk you through another namespace that I have already created here, CIA demo, which is active. I can go into this CIA demo namespace and see all these resources are now available for me to consume. So, example, virtual machines. You can deploy and manage the virtual machine using Kubernetes APIs. And create the TKG clusters. You can create the storage, like for your persistent volume requirements or patching volumes to your virtual machines. You can create the storage here. You can also create the networks, like load balancers that you need for your web servers or load balancers that you need for your TKG cluster. You can create those here as well. And you can leverage the VM images. Now, the VM images could be for your virtual machine form factors. This could be your images for your TKGS clusters and things like that. All the images can come in here. And then, as I mentioned, the database capabilities with the CCI as well now available. I'm going to touch base this into the next episode. So hold your thoughts around this. We will cover this into the next episode. Okay.
Quickly on that VM image. So is it backed by our content store or is it coming from somewhere else?
Yes. So essentially you create a content library and in content library, you expose that image and now that image being used here for the virtual machines.
Got it. Yeah.
So let's see that. If I quickly go into this, see you have options like virtual machines, what t-shirt sizes are allowed for this particular customer or this user. So only medium and small, no large available for this consumer to use. So let's go ahead and create a new VM. VM, I'm going to give a name like episode 3 demo. Right. Now you can see these are the couple of images. Those are coming from the content library. So one I have created for Arya, one is for Kubernetes local. So I can use any one of them as long as they're compliant. So I choose one of the image, right? Over here, the t-shirt sizes that I need to select. So small or medium. So small is 2 CPUs or 4 GB RAM. Medium is CPUs 8 GB RAM. So I select small just for this demo. Now this is where the storage part comes in. So I'm using my policy-based management based on the vSAN. So I have already made available this storage class based on the this particular policy, right? Now, if I want to go into the advanced settings, I can obviously go into the advanced setting. And for this particular VM, Ubuntu VM, if I need a persistent volume, I can select persistent volume. So PVC. Again, using my storage class, which is based on the vSAN software-defined storage, and I can say I need additional 40 GB of volume, right? I can say save. So the 40 GB appears here. And if I have SSH keys to manage the pseudo words, I can put the SSH keys right here to manage the SSH principles. If I need load balancers, I can create load balancers or use existing load balancers when I provision this VM. So for example, if I say new load balancer, you can see it asking me all the necessary information that you expose as part of the load balancer, like the ports, the protocols, the targets, and things like that. If you want to use existing load balancer, you can select existing, and then it lists down the existing load balancers for you to consume. This is based on AVI, by the way. Some of these load balancers are from the AVI. AVI advanced load balancer that we offer. Now, another important thing, the cloud I need capabilities. Now, this is where you can define some of this bootstrap scripts or the configurations that you require for your VM, like install the particular package, set up this user, and things like that you can define. Now, the moment I say next here, before deploy VM, I want to bring your attention to this particular code that is being created here, right? So again, this is using Kubernetes APIs to create the virtual machine. And that's why this is called VM service as part of the supervisor services that we offer with VCF. So I can deploy this VM. And now let's see, it is first creating the storage, the persistent volume. Then once volume is created, it will go ahead and deploy this VM. And soon we will see the VM is up and running. Okay. So this was the VM service that I spoke about. And by the way, the episode 3 supervisor namespace is ready as well that we created previously.
That's available.
So now we consume the existing one, like CIA demo. So we just now created a virtual machine. Now let's go ahead and create TKG cluster. So this TKG cluster, basically, it will consist your control plane nodes, the master nodes, as well as your worker nodes, with some additional parameters if you wish to. And then it will spin up that cluster, which you can then consume to create the pods, the services, the deployments, and other things. So let's create one. Like there are a couple of options you get when it comes to the cluster type, and it gives information. So the cluster class API is the newest cluster API that essentially a lot of people uses. Then the Tanzu Kubernetes cluster API also being provided here for the backward compatibility and the legacy offering in case you want the version which is already deprecated, right? But then let's use the latest one, which is cluster class API. I want to create a custom configuration for my TKG cluster, right? So I set the custom configuration. Quick next, what name I want to give it to my cluster? I'm going to name it like episode 3 demo. Okay. The cluster class again is already defined as a pre-work. So I select the cluster class. The release, I have option here to select what TKR release or Tanzu Kubernetes release I want to use for this cluster. Like
this is all upstream compliant, right?
Correct, exactly. This is conformant, right? So I select 1.26, which is the latest one. I select that my cluster. Now I have given option here what kind of CNI or networking that I need, Entria or Calico. So I use Entria, right? If you wish to define the pod sider and services sider, you can do so, but I'm going to keep it simple, keep it standard, right? Now, do I need persistent volume storage for this cluster? I can use my management storage policy, which is again based on the vSAN as part of the VCF, which provides software-defined storage. I can click quick next. Now, this is where it asks me how many control planes or the master nodes that I need, right? For development environment, probably I can keep it 1. For test environment, I can keep it 1. But for production, I need to select 3. So it gives me high availability at the control plane nodes as well. So for this demo, I just keep it simple 1. Then the VM class, which is basically the t-shirt sizes based on your compute resource requirements. I control nodes. I'm going to keep it onto the best effort small, 2 vCPUs, 4 GB RAM. Again, the storage class is going to be based on vSAN storage-based policy. Now, this is important aspect here, TKR OS image. So what image that you need for your control plane nodes, whether you need for one or Ubuntu, I select Ubuntu, right? Now, do I need additional volumes onto the control plane nodes? I don't think so, but if you need, you can add those volumes. Quick next. Now, this is the node pool, which is basically your worker nodes, right? So I can select the worker nodes here. What name I want to define for worker nodes, I keep it default. How many replicas do I need for my worker nodes in TKG cluster, Kubernetes cluster? Probably, since this is test environment that we're showcasing, 1 control plane node and 2 worker nodes, right? So I select 2 replicas. Again, the t-shirt sizes for my worker nodes, how many CPUs and the memory that I need. So instead of small, I select medium here because more load going to be on the worker nodes to host the services deployment pods and secrets and things like that. So I make it medium. I can select my storage class. Again, the same thing. What I need for my OS into the worker nodes, I need Ubuntu. And if I wish to define some labels that you usually define for your cluster nodes, worker nodes, and things like that, you can define those. And say quick next and finish. Now, I have defined control plane. I have defined my worker nodes pool. Quick next here. Before I review and confirm, I want to bring your attention to this particular code. Again, based on the Kubernetes API, it really develops the code for me, whatever I'm doing here. It gives code. I have ability to download this code as well. So in future, if I want to edit this particular deployment or make changes, I can refer to this particular code.
Right.
Okay.
Right.
Let's go ahead and quickly say finish. Now you can see here, this is being created.
Being created, yeah.
So soon we will see the Kubernetes cluster also gets created. While our cluster is also being created here, let's see existing cluster that I've already created. For example, this TKG cluster that I created in past, you can see here, it provides you all the details. Now you can download this kubeconfig file in order to connect to this cluster. So let's go ahead and do that.
Yeah, right.
So I have already moved that file here. You can see that's the kubeconfig file that I downloaded and moved it here.
Yeah, right.
Clear this. Now what I'm going to do is, as you know, I don't have access to the vCenter directly because I'm the consumer, right? I'm not the provider. So in order to use this API commands, what I can do is I can consume the CCI through the Azure Automation, right? Because I log in into the Azure Automation using the cloud admin account.
Right.
So use that here. Let me log in quickly. So Satya, you can see there are several kubeconfig context has been provided to me to consume, but what we're going to do is we're going to use our CIA demo.
Yes.
So do that. So kubectl-config use context. CCI is our main construct, mod is our project, and CIA-demo is our namespace, right?
Yes, yes.
So now I logged in into the namespace. What I'm going to do is let's quickly check what's going on with our cluster, right? So for that, I'm going to use kubectl get knows the kubeconfig file. And this is a config file we downloaded from the Azure Automation for our TKG cluster.
Yes.
And immediately we can see it is running one control plane node, control plane, and one worker node.
Yes.
Right? On version 1.26.
That's
okay?
right, yeah.
We can quickly also check if you wish, like kg pods -a -o wide the kube config. This particular kube config file once again.
Yeah.
To see all the pods that are running.
Excellent.
This cluster.
Tons of them.
We are able to access the cluster. We are able to consume it. We can create the services, deployments, and things like that.
Yeah. Right? So you can use all the CLI commands here, right?
Yes, we can. So now we are here and we have shown how to create the VMs and how to create the TKG cluster. I want to quickly show you the network. So now you see here in the network service, we're also able to see the load balancers are being created automatically for you. So the TKG cluster that we created, episode 3 demo. For the control plane, there is a load balancer that is also created here. You can see here. Yeah, cluster IP and the external IP they're available for us.
Yeah, right.
The type is a load balancer, which is based on the AVI. So all these things getting created automatically using the Azure Automation CCI integration that we have done. All right.
Right.
Now, what you have seen is basically using the service broker. But then, as I mentioned, there is this new addition into our CCI using the CCI elements. So, for example, now the cloud templates, right? So what I can essentially do is I can go into any of this cloud template and create the cloud template using the CCI construct. So here is the search. We've seen this in the slides as well. So supervisor namespaces, supervisor resources, and TKG resources. So this is something that I have created here. Now, let me walk you through really quick. What is this? So now, what I'm doing here is I'm creating a namespace, right? Using the CCI supervisor namespace resource. I'm defining the input conditions like somebody has to provide the namespace name, the class name, and the region name. Remember the region and class, like where you want to deploy which cluster. So this is the namespace. Now, this also namespace needs some other details, like this namespace we are creating TKG inside it, right?
Yes.
Now you're using the supervisor resource. Remember, the supervisor namespace is one construct. Then there is a supervisor resource like TKG clusters, the VM services, the load balancers that we spoke about. So here I'm also creating a TKG cluster inside that namespace. And then if you see here, this one, these are the TKG resources. Now, the TKG resources that I mentioned, if you have your TKG cluster, you can create deployments, services, secrets, as well as the namespaces within your TKG cluster. So that's the namespace here that I'm creating. And the resource type is the TKG resource. Now, the other important thing I want to bring to your notice is the front-end web server. These are all microservices based. So in this front-end web server, we're also using a TKG resource because this is going to be a web service. Remember, as you can see here, front-end is also depend on the service here. So this is full service that you create into the Kubernetes, right? The service, the deployments and things like that. So my point here is that now you can use the manifest files to define your Kubernetes construct that you need, the services that you need, the deployment that you need. Previously, before the the 8.17 release, 8.17.0 release, you could only consume this from the self-service portal, the earlier demo that we show, right? But now as a provider, you can package this entire microservices architecture using CCI and then publish this using the version control. In the previous episode, right? Now, once you version control this, you release this into the system. If I go back into the service broker, which is the self-service portal, into the catalog, I can see the electronic store app based on the CCI Kubernetes architecture is available for me to consume. So I can request this. I can put details like episode, demo, September, like this. Then obviously we need the MySQL virtual machine. So what we're doing here in the entire blueprint is the MySQL DB is running on a VM service. Everything else is running on the Kubernetes TKG cluster. Right?
All other containers.
Yeah. So now this is MS SQL DB. That's the VM name that I want. What is the name for my TKG cluster? So I can keep the same name here for my TKG cluster. Right? What is supervisor namespace? Again, see, this is picking the information based on the input parameter, which we have defined in the predefined properties. So supervisor namespace is gold. The region is Singapore BBC. Now, how many worker nodes that I need? See, earlier we did it using the supervisor namespaces option here, but now we are consuming this using a catalog, right? Then the t-shirt size for my MySQL virtual machine. So let's keep it small. It's the name of my supervisor namespace. So I'm going to keep it same like episode demo September. Any control plane nodes for my Kubernetes I need? Maybe I keep it 1, or for higher, you can keep it 3. And then the t-shirt sizes for your worker nodes and the control plane. So my worker nodes I need probably medium, but my control plane is a small. Now, once I submit this, I'll get a application with all the necessary construct like this SQL virtual machine, the Kubernetes clusters, the namespaces, the supervisor namespace, the namespace within my cluster, the services, web services, as well as the other secrets that we are doing. See, now, just to save time, because we are doing a lot of things in this particular blueprint, as you've seen, I'll quickly show you the one that we have already deployed.
Let's have a look.
So Satya, while waiting for the other deployment, I have this existing deployment. I'll just open this, and you can see here, I can show you the topology really quick. So this is the microservices-based application that we deploy. We are creating a namespace, right? So that's the namespace. We are creating a TKG cluster. Within TKG cluster, creating another namespace. We are creating PVC. We are also setting up the front end and web service using the manifest, Kubernetes manifest configuration. We have the database service as well, the Kubernetes. So this is all that we're seeing into our blueprint. We are able to deploy this. Now, if I go into the overview, since we are format 2 for this blueprint, we can define some parameters like this. So once your application is deployed using microservices, I can get the OpenCard load balancer IP that I need to consume. So if I quickly click on this, the fully loaded application is available for us to consume.
Excellent.
Exactly. So this is what I was talking about. So you can consume the Kubernetes automation using the CCI UI available into the self-service portal, right? The service broker. Or now with the latest 8.17.0, you can consume the CCI elements within the cloud template, package it as a catalog, and publish it for your consumer to use it. So Satya, just to revise what we have seen, we were able to create the virtual machine using supervisor VM service. We were able to create the TKG cluster using the TKG service within the supervisor. We able to log in into the TKG cluster. We saw namespaces, the context, and the pods and the list of nodes for that particular cluster. Then we saw a load balancer service, how it can create new load balancers for you based on the AVI supervisor service. And then everything can be wrapped around and packaged as a blueprint and then published into the catalog using the cloud templates. We have also seen that. Essentially, there are various ways for us to provide and consume this service. As a provider, you can provide it using the catalog services. As a consumer, you can consume it as a catalog service, or you can directly consume from your as well. And the APIs and UI.
Excellent, man. That was a fantastic demonstration. As you can see, VCF Automation's Kubernetes capabilities are truly impressive. Nice one. And like you said, there are lots of different surfaces we can consume it, right? Either through CLI, API, or the self-service catalog. Awesome, man.
Absolutely. That's pretty much we had for today's episode for Kubernetes automation.
Awesome. Thanks, Pramod. Really appreciate your time. And thank you, everyone, for watching. So join us in our next episode for the insights into database automation. Until then, have a good one, everyone. See you later.